Yeah, so I think what we're actually going to see, this is what I certainly hope anyway, I think we're going to see new applications come through that we've never even thought about. And so it's great that every now and again I have a conversation with someone just randomly on the bus or something like that, and they'll come up with, you know what 3D printing would be good, because everyone has an opinion. And I think there's going to be so many of those opinions coming up that actually, even if 0.5% of them were good ideas that turned into something. So yeah, that's not quite a very specific answer, so no one can call me out on that afterwards in 10 years' time. But that's what I really hope, is that with some of the good side of the hype, people will really start thinking and go, you know what, here's a problem we didn't think we could solve with technology, but yeah, we can. That's what I hope.
Yeah, no, I would kind of agree, and I don't think people say, oh, it's going to take over the world, additive manufacturing is going to take over the world. No, I don't think it is going to take over the world, or it's going to replace subtractive manufacturing. No, I think we're going to just see them simultaneously together, really, more inclined, more together.
Totally agree on the proliferation of applications. I do also think it's going to manufacturing is going to become more distributed and much closer to the consumer, whether that's an industrial consumer or a consumer. And I also I just think it's going to get much wider, and I do think it'll become more of a commodity, and I think we'll see a lot more hybrid technologies that are both additive and subtractive within the same framework, and it will get the best of both.
For me, and kind of based on the work that we do a lot, it's all about multi-materials. So most of the processes you see today are single materials, and for me the future has to be multi-materials, whether we're talking about pharmaceuticals or electronics or whatever. And that is really exciting. It means that we have to bring in people from other industries, which comes back to the multiple applications things. So we need biologists, we need chemists, we need physicists coming in, because they're going to bring their knowledge of the applications that we want to apply the technologies to, and then once we've got them in, then we can start to design the products using these multi-material processes.
Just on the issue of proliferation, the one example that I think comes up every time people talk about kind of scepticism on the proliferation of the counter-argument to scepticism on the proliferation of additive manufacturing is going to be, 70 years ago everybody thought that nobody would ever have a personal computer in their homes. And now we do. I mean, we not just have them in our homes, we have them in our pockets. But, and the thing that's really important to remember is the computers we have in our pockets are unrecognisable compared to ENIAC or the Baby, the early computers that were the size of this room. And we use them in completely different ways. Our use of smartphones and laptops and things is completely different to what the early computers were used for. So if there's going to be something like this in every home, it's not going to look like anything that exists today. I think it'd be very exciting. I think there's a reason to be excited about all this stuff, but it's also kind of beyond the threshold of prediction for now.
What a great way to end it, I think. Very good. Okay, so I think, how long do we have for questions?
15 minutes.
Okay, 15 minutes. So who wants to... This guy, gentleman here. Should we pass this around, or...?
I can sort of all shout and you repeat
Go
it.
on, shout and we'll see.
I can project. Full disclosure, I work in a fab lab where we're doing sort of day-to-day stuff with additive manufacturing. And the key thing we always find is it's the phrase managing expectations. I mean, small children coming in the age of 9, making little playing pieces for their game, for their homework, that's brilliant. The architecture student in the 3rd year sending me a 1-to-1 scale model of a building and wants me to print out as a model. That's where we got a problem. And you mentioned, obviously, the famous the gun incident. 4 years ago, we were sent photographs of elements of a 3D printed gun from Manchester Police. Turned out they were parts for a 3D printer. So it's about managing the Daily Mail and others who will hype this up. And I wonder whether that links in with you touched on IP. How do we protect people's intellectual property rights with models? You can watermark things, you can copyright some things. What do we feel is the way forward for that? Because obviously artists and designers need to have their ideas protected.
I think there's that's where it comes down to joining all the dots with the whole sort of the framework of a digital enterprise, and you can build into the software the protection for making that model into a physical model, and it's about, like I say, joining up the dots to make sure that the protections are built in before it becomes a physical reality.
I did a study a couple of years ago commissioned by the Intellectual Property Office to look at the impact of 3D printing on IP. And I'll be honest, the outcome of it was that the IP system that we have in this country will protect the designs created by 3D printing. There is nothing about 3D printing that makes it special in terms of IP. The only thing it does is it makes it easier to replicate things should you have the original CAD data. But that's the crux of it, is getting the original CAD data. Actually, that's really hard. It's like saying, I'm going to get the engineering drawings for a 747. You're not going to get hold of them. Unless. But seriously, it's no different. And I think that there are intellectual property challenges. So one of my favourite examples is, if you've ever heard of Bugaboo prams, which are very expensive, you can go onto Shapeways, which is a 3D printing website, and you can buy spare parts for your Bugaboo pram off Shapeways for a fraction of the cost that they are from Bugaboo. That's because a guy spent his spare time CADing up that part and then putting it online and making it possible for you to buy. And he's absolutely in the wrong. Bugaboo could go after him on UK copyright law and get him. So it's just the fact that it's easier and it's possible for him to do it, but the framework does exist for him to be prosecuted.
I suppose it's more about policing it. So you need more people to go out and say, okay, that guy's doing that guy's doing this, you know. So
Just make the current infrastructure aware of it.
yeah, and I don't think a lot of companies are aware at the moment. And I think we need to raise that awareness, and hopefully that issue will go away. Okay, yes, sir.
Yeah, I have some issue with this legalese stuff, because the law is always 20 years behind. And if we take care of having the law doing something, we would still be up in the trees. I mean, we can't do that. The way to go forward is most often to break the law. Let's face it. The other thing...
Didn't condone that.
The other thing I was going to say is, I remember in the 80s when I was starting doing 3D printing, in the 80s, yeah. Okay, that DARPA was doing laser printing of gun barrels. So it's been around for a long time. And at the moment, DARPA is using significant amount of money to make exoskeletons. And you need to be able to make exoskeletons for every single person. And you know how sloppy people are when they make new people. So they're all different. And you need the 3D printing. Okay, that was, I know what you wanted.
Cheers. So, thinking of aerospace applications for 3D printing, I know there's a lot of, the vast majority of aerospace alloys will be quite heavily, a lot of them are very heavily rolled to develop a very distinct grain structure. Is there any scope for that kind of control over the grain growth in 3D printing at the moment? Because that seems like quite a significant drawback.
I can answer that question, but I can't answer that question here. Just because we do have a grant, and we've actually filed a patent on this 3D printing of metals that are high speed, but also have the properties of similar, conventional manufacturing of metals. But I'm not prepared to say what that is in public because unfortunately that would shoot our IP in the foot, if you like. But I'm happy, Alex, to talk to you on a one-to-one basis about that. Sorry, I couldn't be more expansive.
So if you look at Cranfield University and the work that they're doing on wire arc manufacturing, which is basically huge welding with robots, the microstructures they're getting off those are phenomenal. And I know companies like BAE Systems are very open about saying that they are good enough to use for wing spars and things like that. I'll be honest, when I first saw it years ago, I thought, God, there's no way that's going to work. You know, you're going to have massive problems between layers and boundary issues and all sorts. And actually, coming from the customer, which I know to be a very demanding customer, they're saying there is no problem and these are good. So.
Any other questions?
From a material science point of view, are there any sort of new innovations coming out at sort of cheaper end of the market or anything interesting?
Yeah, so I think it's, in terms of the materials, there's a couple of things. So one is materials are traditionally really, really expensive for these techniques. So you have that conversation with someone and you go, yeah, you can do all this complex stuff and you can add value through lightweighting or optimization, and then you get to that point where you say, oh, and the materials are just a tiny bit, by which I mean a lot, more expensive than the others. So certainly on the polymers side, we're starting to see a lot of increased competition in that area, which I think necessarily will increase the range and bring the prices down. I think we're also starting to see more work looking at actually making the parts more active, if you like. So this isn't a sales pitch, but I've just got some funding to do some work looking at making antibacterial polymer parts. There's obviously work going on looking at high temperature parts, cold temperature parts. So a lot of times traditionally the part has just been a part and it's right, this is the shape I want, this is the size I want it, let's stick it in. But I think there's loads of good work going on all over the place looking at what can we do in a sense of materials to give the part something more interesting or something extra and make it actually do something other than sit there as a shape.
There's also a company out there called Mark Forged. They're an American-based company, I think, aren't they? So they take, your conventional printers, what you would class as a 3D printer, these extrusion presses, and instead of just the polymer, they've got Kevlar in there, nylon, carbon fibre, glass fibre, and they're now cheaply producing quite bespoke parts, but have the physical properties of metals, or simulate the properties of metals, and they're much, much cheaper. You can get a cartridge of that, I think it's around £150, something like that. So a little bit more expensive than your traditional filament for it, but much more varied properties of materials.
And one other company that is changing its business model around the pricing of its materials is Carbon, and they're out of the United States as well. But they announced just last month actually that they are reducing their materials pricing based on the volume sold, and their latest customer is Adidas, who is looking at 3D printing over 1 million parts next year on their machines with their materials. And they've also got 2 automotive clients as well that are about to announce production applications with their materials, and they're saying the more applications at the higher volumes, the lower the price of the materials will be, which is really interesting actually.
And my favourite one at the moment is a company called Photocentric, who are based in the UK, which in 3D printing world is pretty rare. And they have come up with a process that it cures photocurable resins. And they're not from the 3D printing world, they make stamps originally, but what their background is chemistry for photocurable resins to make stamps. And they are targeting, their price point is they want to go for £5 a kilo of resin. The Carbon process, they've just done a press release, they're really proud. I think they're down to 150 at the moment, £150 a kilo. So what Carbon are going for, what Photocentric are going for is so off the wall in terms of where we are at the moment. But you know what? If a company like that can do it for another industry really commits, I don't see why we can't get there. So I think we could see a real step change in material costs.
There's more competition as well now, and as patents lapsed in 2009 for FDM and in 2013-14 for SLA, you start to see more and more people producing different types of materials, cheaper, kit, because before it was just one big company really selling all these techniques and nobody else could touch it because they had to pay these guys lots of money for their patents. Now there's labs, you start to see much more cheaper materials, in higher volumes, I think, how many more questions, Lisa? Two more, okay.
When you talk about additive manufacturing, you keep going back to it being quite a disruptive technology. And we've seen, particularly over the years, as new manufacturing methods come in, there's always a bit of a delay. So whether you consider that part of like the technology readiness process, or whether it's just a limitation of materials you keep coming back to. But do you think that, I guess it's more of a philosophy standpoint, do you think that both engineers and designers at Current have the tools or the underlying foundations to actually think in an additive form? Can they, so the way that design for manufacturing assembly will change as a result of that, do we need to go back to the fundamentals, the total designs and Paul and Beitz's of the engineering world, do they need to actually be reassessed as part of this? And do you think that there are any particular technology drivers, so possibly, as you mentioned, Siemens with their large energy backing, do you think possibly photovoltaics, where you're working already with thin layers, do you think that there would be a driver for that? Or do you think that that would have to be more of a thought exercise before industry take it on?
Yeah, so it's actually, there have been lots of conversations, I mean certainly in the UK but probably worldwide, about skills and that knowledge base. And so one of the things that's come up is loads of people are getting machines in, so even forget the kind of next level of where the technologies are going. People are getting machines into a company and then going, oh, pardon my language, oh crap, what do I do with this? And because there are lots of things and there's lots of, what I would do, I'm not a designer, but if I was, what I would do at the design stage has an impact on what process I use, the manufacturing method, what I've got to do to that part afterwards to get it ready. And that's just one example. So there's so many intricacies of it that I think some of it means we need to stop thinking of these people are doing design and these people are doing manufacturing and these are the mechanical engineers and these are the chemists and so on. And I think there is also, and we're starting to see a bit of a move towards it with certain initiatives, but there is also a need for that kind of more creative approach to things. So an example I like to give is, okay, if something goes wrong and that part doesn't come out how we intended it to, I may not have seen that exact problem before, but do I know what it could be? So, can I look at it and say, I think the top 3 things it might be that have caused this are this, this, and this? Or do I look at it and go, well, I've never seen that before, I don't really know what to do, let's call someone in, and in that situation, who do you call? Because we don't have that many skilled people at the moment. So I think there's a bit of a rethink in how we separate things and how we look at problem solving.
And we should point out that these technologies are not new. They've been around, 30 years. It's just now that it was called rapid prototyping. It just made prototypes, and now go back to, I know again, I'm a material scientist, but it's the materials, and it's bringing on board a more diverse, research team. So people from biology, from physics, from chemistry, and saying they didn't think they had anything to do with additive manufacturing or to offer additive manufacturing. Well, actually, they do, because they understand the fundamentals of how these materials work and how we can get them in a 3D printer, and that's what we need to do, bring more of these people in. Okay. Yes, and philosophers. No, I think we do. We need to think of all of challenges, not just additive manufacturing. We need to think right across the board, get the humanities side in, science side, everybody working together to solve these challenges. So I think we've got a chance for one more. Is there anybody else who hasn't asked a question or wants to ask a question? Is there a gentleman?
So as you said that the technology has been there for 30 years, maybe longer, and it will be there for a long time, I think. So my question is, for the next maybe 5 years, so what do you see that something that can make a real impact on the market, or some niche application or killer applications the 3D printer will bring, just for the next 5 years?
Can we say our own research? So I actually think we've talked quite a lot about the medical side. I think we will start to see increasing amounts of work in that area, but I think some of it won't be the kind of enhancements and the Wolverine type thing, because there's lots of examples of using these technologies for surgical practice. So I go in to do an operation, and I seem to be a surgeon now as well, but I go in to do an operation and I've had a chance to practice exactly how I'm going to do it, identify any issues. There's actually some really interesting work which ties in with materials of people looking at visualizing things during scans. So if you had a CT scan, which sounds very, very miserable and a bit of a downer, but you need dead bodies to practice on in certain cases for things. And so to be in that situation where actually we can recreate something that looks exactly how it would look. So if this was a real human being, this is what it would look like. And so training people for those applications even as well. And so it opens out into so many areas where it can impact on the medical sector that I think we'll see lots of breakthroughs coming through. I also think there'll be lots of breakthroughs in that area that we probably never see because they just make everything better and more efficient, but they're not the making Wolverine stories, but I think there'll be a big impact there.
The one I'm really excited about is pharmaceuticals, which I've said a couple of times, and we can be printing pharmaceuticals for a couple of reasons. The first is tailored dosages, so instead of you taking 20 pills, you'll take one pill that's tailored to you and you know how it's going to react. Or tailored release rates, optimised release rates. And that's really exciting and interesting. And I think once we can show that works, it will be a massive step forward for us, and we'll be able to do a lot more research in that area.